Hi guys, we're starting section 7.2 today, properties of exponential functions. Learning targets today and what we're shooting for are, I can explore the properties of functions of the form y equals a times b to the x power, and I can graph exponential functions that have base e. So big ideas here are, the factor a in y equals a times b to the x power can stretch or compress and possibly reflect the graph of the parent function. We know that's what our a value does. Okay, it's done that for absolute value, it did it for quadratics, it did it for polynomials, it did it for square roots, it did it for cube roots. Okay, so we know that's what our a does. It's a stretch or a compression, and if it's negative, it reflects. The function y equals a times b to the x power, as long as a is positive, b is bigger than 1, models growth. If b is between 0 and 1, it models decay. And we talked about that last section. So if we look at the graphs on the bottom of page 442, we have two different graphs there. We have a red and a blue. The blue graph shows 3 times 2x, and the red graph shows our original y equals 2 to the x power. So when we graph something times b to the x power, we can use our a value to graph that. So in example 1, it says, how does the graph of y equals negative 1/3 times 3 to the x power compare to the graph of the parent function? Well, we're going to start with our parent function. So we're going to start with y equals 3 to the x power. Okay, when we look here, the negative is going to be a reflection. And because it's the whole function, it's going to be over the x-axis, which means it's going to reflect it this way. Okay, and the 1/3, since it's less than 1, is going to be a compression factor. So it's going to kind of smush it all down. Okay, so we don't actually have to graph it there. If you look on page 443, they did graph them both, but we know about stretches, we know about compressions, we know about reflections, so that's all I did there. Okay, I'm going to give you guys a second to try this one. Go ahead and pause. When you're done, come back. Now, how does the graph of y equals negative 0.5 times 5 to the x power compared to the graph of the parent function? Well, our parent function here, where we start at, is y equals 5 to the x power. Again, this negative is going to reflect over the x-axis. Because it's right out in front, we're going to reflect over the x-axis. And this 0.5 is a compression because it's less than 1. It's a compression factor. It's a half. Okay, it's going to smush everything by half. Example 2 says translating the parent function, y equals b to the x power. How does the graph of each function compare to the graph of the parent function? List the range, asymptote, and Y-intercept. Okay, so we have a change here, a -4 inside with the x. So when we have things with our x, we know that's going to be left and right. Since it's -4, we're going to go right 4. That's our translation. So we're going to start at y equals 2 to the x power, and we're going to go right 4. Okay, now it says list the range, asymptote, and y-intercept. Did we go up or down at all? No, we don't have anything here. So since we didn't go up or down at all, our range is still going to be the same. It's going to be all real numbers greater than 0. Same thing, we didn't go up and down at all, so our asymptote didn't change at all. Our asymptote is going to be y equals 0. Y is never going to be 0. The only thing that's going to change is our y-intercept. And again, remember, to find our y-intercept, we plug a 0 in for x. We get y equals 2 to the 0 minus 4. Y equals 2 to the negative 4 power. Remember, with that negative exponent, it's 1 over, we take it to the denominator because of this negative exponent, and we make that exponent positive in the denominator. So 2 to the 4th power. 2 to the 4th power is 2, 4, 8, 16. So our y-intercept is 1/16, or 0, 1/16. Okay, they do have those graphs drawn on page 443 as well. We wouldn't need them, but it's okay to do that as well if you want to. As far as B goes, we need to know the transformations, range, asymptote, and y. So transformations, the function we start at is just y equals b to the x power. Okay, we have this 20. That's our a value. Okay, so the 20 is a stretch factor. The 10 on the end, since it's not with our x, means it's going to be up and down. And here we're going to go up 10. So that changes everything that has to do with our height. Because we went up 10, that's like our y value. So that's going to change our range and our asymptote. Okay. Okay, let's plug this in. Our range, instead of being all real numbers greater than 0, now we're going to have all real numbers greater than 10. That's whatever our k value is, that number added on. That's always going to be our range number. Our asymptote is going to be y equals 10. Always going to be this k value. Since we shifted up 10, that shifted our asymptote, it switched our range, it shifted everything up 10 units. Okay, everything, it was like we just picked it up and moved it up 10. Now, as far as our y-intercept goes, again, to find our y-intercept, we make x 0. So y-intercept is going to be 20 times 1/2 to the 0 power plus 10. Remember, anything to the 0 power is 1. And our y-intercept is going to be at 30. Okay, y-intercept is going to be at 30. And they have that drawn at the top of page 444. So if you wanted to look at the graph there, you certainly could. Okay, our domain didn't change. Our domain never does. Our y-intercept changed, our range, our asymptote all changed, but our domain stayed the same. Now, how does the graph of each function compare to the graph of the parent function? Lists the range, asymptote, and y-intercept. I'm going to let you guys pause here, and when you come back, we can work through these. So go ahead and try it. Okay, our range, first of all, our transformations. So we're going to start off with our parent function. Y equals b, which here is 4, to the x power. Now we have a plus 2 in with the x. So since it's inside with the x, it's going to be left and right. Since it's a plus 2, it's going to go left 2. As far as our range goes, since we didn't change anything up and down, our range didn't change. Our range is going to stay all real numbers. And our asymptote, again, since we didn't change up and down, is still going to be y equals 0. Range is all real numbers greater than 0. Sorry about that. Our domain is all real numbers. Our height didn't change, so neither did our range or our asymptote. Our y-intercept, to find our y-intercept, we make x 0. We have y equals 4 to the 0 plus 2 power. Y equals 4 squared. So our y-intercept is going to be 4 squared, which is 16. So we went 2 units to the left. The y-intercept becomes 16. Our range and our asymptote did not change. I'll give you guys a second to try B. You can go ahead and pause. Okay, our transformations, we start off with y equals b to the x power. Two things happening to b right now. We have this 5. Since we're multiplying, it's our stretch factor. We're going to multiply our y since we're multiplying there. It's our a value. So stretch factor. Our second 5 is added on to the end. So that 5 is going to move us up. Those are our transformations. So we stretched the original graph by a factor of 5 and translated it up 5 units. Okay, now our domain is all real numbers. That never changes. Our range is our y values. So all real numbers, since we went up 5 instead of being greater than 0, we're going to be greater than this 5. Our asymptote follows. Remember, range deals with y's, your asymptote is a y. So if we change our height is a y. Y equals 5. Last thing we need to do is find our intercept. So our y-intercept, to find our y-intercept, we make x 0. 5 times 0.25 to the 0 power plus 5. Remember, anything to the 0 power is 1, so 5 times 1 plus 5. Our y-intercept is going to be at 5 plus 5, or 10. Okay, that's where I'm going to stop for this one. We are going to run out of time on the recorder, so I'll start up again with the next problem.